Hey guys, back again. Looking at 4.4 of the counting rules, this is a really easy lesson. Hopefully it won't be too difficult for you. The first part is the fundamental counting principle, and really what this says is if we have multiple things, multiple different things that we're looking at, events, then you can multiply their possibilities together to get your total number of possibilities. Okay, so the easiest way just to do this is to look at the examples. Alright, so on example 1, it says a coin is tossed and a die is rolled. A coin is tossed and a die is rolled. So we're talking total possibilities here. So for a coin to be tossed, how many total possibilities to toss a coin? Toss a coin. How many possibilities are there? Well, there's 2, heads and tails. To roll a die. How many possibilities do we have there? 1, 2, 3, 4, 5, 6. That would be 6 total possibilities. So when we're talking our total number of possibilities, this is the fundamental counting principles. It says we'll take 2 and we'll multiply it by 6, and that will give me 12 total possibilities. Okay, so we just take each of their outcomes and multiply it. So example 2, very similarly, it says a paint manufacturer wishes to manufacture several different paints. Okay, so if you've ever been to Home Depot, you've seen where you go and you can buy paint. Well, I always thought that you could just pick out the pretty color and that would be it. But no, they ask you all these questions, whether it's an indoor or an outdoor paint. I can usually answer that. But then when it talks about semi-gloss, high gloss, eggshell, not eggshell, I'm completely confused. So there's lots of possibilities here. For this one, we have just these colors to choose from, these types, these textures, and these uses. So how many different kinds can we get? That's what it's asking. How many different kinds of paints? Alright, so for the color, we have 1, 2, 3, 4, 5, 6, 7 possibilities. For the type, we have 1, 2. For the texture, 1, 2, 3. For the use, 1, 2. So we multiply all those together. And that would give us our answer, which is 7 times 2 times 3 times 2. 84 possible different kinds of paints. Okay, for example 3, it says there are 4 blood types. So 1, 2, 3, 4 blood types. Blood can also be Rh positive or Rh negative, so that's 2 possibilities there. Finally, the blood can be male or female, and that's 2 possibilities there. How many different ways can the blood be labeled? So it'd be 4 times 2 times 2, which is 16 ways to label. Legitimately, probably one of the easier lessons we do. Now, the only hiccup comes when we do stuff like example 4, where it says in some situations, repeats are not permitted. Okay, so in this case, a manager at a department chain wants to do a 4-digit ID card. Okay, so that means that there are 4 spots for numbers. So I like to put in X's as placeholders so that I can see those 4 digits. It says how many different cards can be made if she uses the digits 1 through 6 and she can repeat the numbers, which means it could be like 1, 1, 1, 1, 2, 2, 2, 2, whatever. It could be 1, 2, 3, 4. How many total numbers does she have? Well, she has 1, 2, 3, 4, 5, 6. So that's 6 numbers. Alright, so for the first number right here, for the first spot, she has 6 possibilities. And she can repeat, so it would be 6 for the second one, and the third one, and the fourth one. So this would be 6 to the 4th power. And you can do that on your calculator 6 times 6 times 6 times 6 is 1296. Now it's a little bit different if she's not able to repeat, because once she uses a number, or he, you can't have it again. So let's say the first number, we have 6 possible numbers we could use. 1, 2, 3, 4, 5, or 6. Once I use a number, I can't use it again. So then I would have 5 numbers to choose from, and then 4 numbers to choose from, and then 3 numbers for the last one. So it would go down. On these, you just multiply. So this comes out to be 360, which is significantly less than the 1,296 we had there. So that's how you do with the repeats, without the repeats. Now, when it comes down to it, a lot of times it'll say how many different ways can someone visit colleges. How many, here, I'll write it down. How many ways to visit, let's say, let's just say for sake of time, 5 colleges. Well, once you visit a college, you're not going to visit it again, not on a visiting colleges trip. So the way this would be was, at first I would have 5 to choose from, and then I would have 4 once I visited 1, and then 3, and then 2, and then 1. Okay, so there would be 120 possible ways I could do that, depending on which order you did it in. Okay, so that's what it wants to do. So it's like arranging stuff on the shelf. That's the way it would be done. Picking bands and comics to go in a lineup. This is the way it would be done. So be very, very careful when you're doing these repeats and not repeats problems. Okay, so I just want to talk about a couple of things with factorial notation. What it really wants you to do is it's not like a super happy 6, okay? This is a type of notation that means we're going to perform an operation, and that operation is multiplication. Alright, so this 6 tells you we're going to start with 6. I'm going to go 6 times 5 times 4 times 3 times 2 times 1, all the way down to 1. Alright, so that's pretty easy to do. We'll go to our calculator. We'll go 6 times 5 times 4. That's not 4, guys. 6 times 5 times 4 times 3 times 2 times 1. Alright, so that's 720. So that wasn't so bad. So 720, we'll put that on there. So the next one, 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, it gets a little more tedious the more you do of these. So I'll do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And I get 40,320. Okay, so the next one is 12. So that would be 12 times 11 times 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1. And if you notice, each time these have gotten more and more aggravating, because they really are just aggravating. Okay, so 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so 4,790,001,600. So that's 479,001,600. That's crazy. Okay, so you're thinking to yourself, well, what if we have 24 or 25 and we had to go all the way down to 1? Well, that would be super aggravating. There is actually a way that we can get that exclamation point on our calculators. So if we type in 6 and then we press the math button and then we go to the left twice, it's the probability. section, and there, number 4 is the one we press. So math, left, left, and that would be what you need to do. Okay, so for the next one, 8, math, left, left, 4. Okay, so there we go there. And then the last one, 12, math, left, left, 4. And we have our answer there. So that should save you some time. I put some calculators that you can find on the web if you don't have a graphing calculator, so you are welcome to use those for that as well. Now the other part of 4.4 in this section is completely calculator based. There's some formulas. 0 factorial does equal 1. You can calculate that on a calculator. This is the same thing we just talked about. If we're doing 6, then we do 6, 5, 4, 3, 2, 1, and so on. Then we talk about 2 things called permutations and combinations. What you really need to know is you use a permutation formula if there has to be a certain order to the different objects. If there is no order or it just says combinations, then you're going to use combination. Okay, so that's the difference there. Now let's look at some examples. Okay, so let's look at these examples real quick. The advertising director for a TV show has 7 ads to use on a program. Okay, so that's important, 7 ads. If she selects one of them for the opening, the middle, and the end, how many possible ways can this be accomplished? So this is how I like to approach these problems. How many total things does she have to choose from? Well, she has 7 things to choose from. How many is she choosing? Well, she is choosing 3. Then you ask yourself, is order important? Is order important? Well, does it mention any words that would make it seem like order is important? Well, it says beginning, middle, end. Those are order words. So, yes, order is important, which means if order is important, then you need to do a permutation. Here is your permutation equation. N factorial over n minus r factorial. Okay, so n factorial, well, n is our total number. So this is n. 3 is the number we're choosing, or the rate at which we are choosing. So the bigger number is going to be your n, always. So 7 is our n, so 7 factorial. And then on the bottom we would have 7 minus 3 factorial. So this would be 7 factorial over 7 minus 3 is 4 factorial. Now, I just showed you how to do this on your calculator, so you could pull up your calculator and do 7, math, left, 4, and then we would divide 4, math, left, 4, and it still is kind of tedious, but you can get there. It is 210. Okay, so this is 210 possible ways. Now, another way to do this, if you notice, if I wrote this all the way out, 7 times 6 times 5 times 4 times 3 times 2 times 1, and then on the bottom, it would be 4 times 3 times 2 times 1. If you remember from algebra, anything that you have in common, you can cancel out. So those would actually cancel, and 7 times 6 times 5, 7 times 30 is 210. So that's just a shortcut if you wanted to do it that way, but you don't have to. Alright, so the next one, a school musical director can select 2 musicals for them to present next year. One will be presented in the fall, one in the spring. If she has 12 to pick from, how many possibilities are there? So her total is 12. And she can choose 2. Is order important? Well, it says fall and spring. Nobody wants to watch Frozen in the spring. Well, I mean, we've been watching Frozen 2 like nonstop at my house, but you get what I'm saying. Order is important, so we're going to use the same equation. So it's going to be n factorial over n minus r factorial. Okay, so this is what it'll look like, 12p2. Okay, so 12 factorial over 12 minus 2 factorial. So this will be 12 factorial over 10 factorial. If you do it the algebra way, then 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 cancels out. And you're left with 12 times 11, which is 132. If you don't believe me, then, or you just don't want to do it that way, you can do 12, math, left, 4, divided by 10, math, left, 4, and then you get 132. Okay, so it works either way. Alright, so moving on. Example 3. Example 3 is not as big of an issue. Just know that there's a difference between permutations and combinations. So I'm going to move ahead to example 4. How many combinations of 4 objects are there taken 2 at a time? Okay, so we have a total of 4 objects, and we are choosing 2. Now this one says combination, which means guess what? We're going to do a combination. So for a combination, that's NCR. The only difference here is we're adding an extra r factorial on the bottom. You don't have to memorize these equations, guys. They're given to you. They're in your notes. So just look at them. Alright, so n is 4. So 4c2. And this is what it will look like. 4 factorial. 4 minus 2 factorial. 2 factorial. Well, what's 4 minus 2? Well, that's just 2 factorial. 2 factorial. Do not multiply those together. You need to leave it just like that. If you're going to do it in your calculator, then you're going to need to put the bottom in parentheses. 4 math left. 4 divided by parentheses 2 math left. 4 2 math left. 4 close parentheses, and you'll get 6. So 6 is our answer there. Alright, now I do want to show you that there's a way to do this on the calculator, a shortcut, of course. There always is. So if you go to your math left, you'll see that there's an NPR and an NCR. The one we just did was a combination, so I'm going to do 3. And we did 4C2, which gave us 6. Now, if you look at example 2, we did 12P2. So I'm going to do math left, and I'm going to do a P2, 12P2. And we got 132, which is what we got. For example 1, we did 7P3. So math left, and we're doing a P, 7P3. We should get 210, which we do. Okay, so that's just a shortcut there on the calculator. I also uploaded the online versions for you, so you can use those. So here we have a newspaper editor received 13 books to review. Okay, so that's the total. So the total is 13. He can use 3 reviews in his newspaper how many different ways, so he can choose 3. Order is not important in this one. It says nothing about a certain order in the paper. So this is going to be a combination. So we're going to do 13C3. So this will be 13 factorial. Then we're going to have 13 minus 3 factorial and 3 factorial. And I'm just going to plug that into my calculator. So I'm going to go back to my calculator, and I'm going to do math left, and we're doing a combination, so that's number 3, 13C3, And there's my answer, 286 possible combinations. Hopefully that makes it a little bit easier for you. Alright, last one. And there's an example like this in your classwork. It says, in a club there are 9 women and 4 men. So we've got women and we've got men. And we have a total of 9 women and a total of 4 men. Now, for the committee, we can choose 1 man and 3 women. So we're going to choose 3 out of the 9 women, and we can choose 1 man. Okay, so in a club. Now, order is not important. It's like draw a name out of a hat here. Order would be important if the person who got the most votes came in first place or became the president or something like that. So be careful with how it is. But in this case, it is a combination. So this would be 9, C3. This one would be 4, C1. Alright, so we're going to get what those are on our handy dandy calculator. Okay, so math, left. We're doing combinations, so that'd be 9C3. Okay, so that one is 84. And then we're also going to do 4C1. And that comes out to be 4. So that's our possibilities there. So there's 84 possibilities for the women and 4 possibilities for the men. But we want to know how many different possibilities total there are. So this goes back to the fundamental counting principle where we said if we want total possibilities, then we take each of the possibilities and we multiply them together. So we're going to do 84 times 14, which comes out to, let's see, 84 times 4, 336. And that's our answer there. Again, most of this section is calculator, and I did upload those calculators, so hopefully that will answer the majority of your questions there. When you get your new packets for Chapter 6, I will go ahead and start working through and doing the notes so that you can see those. I put some charts in there that you're going to need, so just be very aware that I'm doing the best I can to upload these videos. Internet has been an issue, upload speed has been an issue, so just be very patient. Thank you.